And get started tonight. So tonight is the last night that you see me for 3 weeks unless you schedule a one-on-one. Ryan will be coming in tomorrow to start talking about networking, APIs, HTTP, and then you will be working your way up to using other people's APIs. And that will all result in your midterm project, which is using the New York Times bestsellers list. And so the reason why we like that project so much is because it really touches on all the different concepts that you've learned of JavaScript, of the document object model, of reading under and understanding documentation, of being able to debug. The reason why we call it our midterm is because it really does cover so many different topics. And so that project is a significant part of your grade. It's worth 20 points instead of all the other homework assignments that are worth 5 points. But I want to remind you guys that I am still here for one-on-ones. You can ask Ryan as well. He should be able to do one-on-ones with you. You might have to schedule with him in Slack. And so just want you guys to keep that in mind. So Ryan comes in tomorrow, Wednesday and Thursday. Then you guys have an entire week off. So the week of July 1st, including all the way up until July 4th, you have off. You come back in, you have another week with Ryan. The capstone project will be due that following July 15th. And then the other thing to keep in mind is we also have a capstone check-in the day that I get back. And the main objective in that capstone check-in, again, is to have a majority of your HTML built out. So you don't need data loaded in, you don't need any APIs, you don't even need any JavaScript. All we're looking for on that July 15th capstone check-in is, hey, if I sent someone this website, it doesn't have to work, it doesn't have to be interactive, the forms aren't going to go anywhere. But if I sent someone this website, would they understand the vast majority of my project, right? And that's kind of what we're shooting for that July 15th. So even though I disappear for almost half a month at this point, I don't want you to think that I am not available. Still reach out to me on Slack, still hit me up for one-on-ones. But you got a great instructor coming in tomorrow to teach you all about APIs and networking. Any questions about the schedule, logistics, where we're headed, any of that good stuff? Okay. We do have our last JavaScript concept that I have to teach you, which is set timeout, asynchronous code, and promises. This is the first time I am actually teaching this instead of Ryan covering it in his modules. And it always seems to be a very challenging concept, not just for new students, but developers as a whole. So I think I have an approach of how we're going to go over this and learn it. But bear with me. Feel free to ask questions or give feedback as we're going through all of this. But I'm not going to advise that you follow along with this because we aren't going to be writing a ton of code for this. This is more understanding the concept and the theory of it than it is actually being able to use it. When Ryan comes in for APIs, you will get a lot more hands-on experience with async and promises and all of that kind of stuff. So I'm going to advise that you don't code along tonight because this should only take us about 30 minutes to go through everything. But if you would like to, you are more than welcome to. Let me pull up the chat before I forget because I have been forgetting to do that. Okay, I am going to fire up week 11. I'm going to create my day one and throw that in VS Code. I'm going to create a script.js and I will start a live share link if you guys prefer to follow along that way. Okay, so we have been writing what we call synchronous code, right? No A at the beginning of that. Synchronous versus asynchronous. Well, what do we mean by synchronous? It means that we start from the top and we work our way down, right? And the only time that we kind of change the order that we're writing our code is when we call a function, right? Because the function says, hold up, let me go up here, let me go do this section of code, this function. When I'm done, I'm going to skip down to this next part and continue running in order, right? So, what we haven't seen is kind of playing around with time. So, we may want to say, hello, wait a second, and then say, how are you doing today, right? So, we can start with a console log, hello. And what I want to do is say, hey, set a timeout. A timeout is basically saying wait a certain number of milliseconds and then run this code. So the second parameter that we give the set timeout is how long do we want to wait? Let's say we want to wait 5 seconds there. 5,000 milliseconds is equal to 5 seconds. And after I wait 5,000 seconds, or 5,000 milliseconds, excuse me, 5 seconds, I want to log out. How are you doing today? And then I am going to log out goodbye. Seems pretty simple, right? What do we expect to happen here? We see hello come out. We see how are you doing today 5 seconds later. And then we see the goodbye when it's done. Well, if I pop this open and run this code, I see hello, goodbye. And then I wait a couple seconds and out comes how are you doing today? And I'm like, well, that's weird. We've never seen that happen before, right? We've always executed from the top all the way down to the bottom. Well, it turns out that this set timeout is running asynchronously. It has basically said, hey, I'm going to throw this in the background and keep on running the rest of the code. Then, when the 5 seconds is up, we are going to go log that other thing out, right? So that can kind of cause some problems. And we need to be conscious of that, knowing, hey, if we're putting something in a timeout, that doesn't necessarily mean it's going to block all of the other code running behind it. So why do we have asynchronous code in the first place? Well, oftentimes we won't control how long it will take for something to happen, right? Let's say we go out to a weather API, which we will be doing once I come back in about a month. Let's say we go out to the weather API and we're like, hey, what's the weather for 13202? Well, that API call may take a while to run, right? We don't get to control the person's internet speed. The API may have to pull some weather data from somewhere else. They may have a database, right? There could be all of these things that we can't control the speed on. So what we may want to do is say, hey, go make that API call and when it is done, this is what we want to do. But while that is running in the background, there are some other things that we want to accomplish. So when that API call is running asynchronously, again, in the background, don't hold up the rest of this code from running. So let's think about this as an oven, right? An oven could have multiple things in it. But we also may be getting ready for Thanksgiving. We put the turkey in. When the turkey comes out, we go, all right, now we got to reheat this next dish. We got to go through all of this stuff, right? So what we're going to do is we are going to make a new function called oven. And the oven is going to get the item that we're putting into it, and it's going to get the time that it's going to take to cook. We are then going to say console log starting to cook. Help if I put that in a string. Then we are going to set a timeout for put our function in so it knows what to do. And we're going to console log out the um, done cooking the item. and that is going to wait for a specific time. Now we get to call this. We get to say, all right, let's go, let's say, let's call it bake instead. We're gonna bake our turkey, and it's going to take 3 seconds. Then we are going to bake our pie, and that is going to take 2 seconds. So we come in here, we run this, and it immediately says starting to cook turkey, starting to cook my pie. And I'm like, well, wait a second. The turkey's got to be done cooking before my pie can go in the oven. So now we've got a problem because what happened here is the turkey went in the oven and it said, all right, I will wait 3 seconds and then tell you I'm done cooking the turkey. But then it came down here and said, screw whatever's in the oven. I'm going to go start cooking the pie as well. And now we run into a problem here, right? Because I need to somehow tell my oven, hey, wait for the turkey to be done, give it the full 3 seconds to cook, then put the pie in. How do we go about doing that? We do that with something called a promise. A promise is exactly what it sounds like. It is a promise that something is going to get done. And we can either resolve the promise and say, we're done with that thing, here's the data, or we can reject the promise. So, in order to do that, we are going to say, excuse me, return a new promise. And what we are going to do is say, hey, that is going to resolve if I can type or reject. Then we are going to set our timeout for the done cooking of the item, and we are going to tell the promise that it is resolved. That promise now has data in it. We then get, because this is a promise, we can then say bake the turkey for 3 seconds. Then and only then should we bake the pie. So if we run this, it says starting to cook the turkey. It waits 3 seconds. It says it's done cooking the turkey. Then it says starting to bake the pie, and it's done baking the pie. Okay, so let's trace through this because I know that this is not fun syntax for anyone, but super important to get this down because asynchronous code is becoming more and more of a part of JavaScript, right? As we're making all these different API calls, as things are running in the background, as we start to optimize our code to be able to do more things at once, we need this notion of promises in order to understand what's happening. So let's draw this out. We say bake. Bake comes up to the function right up here, and it says, all right, we're baking the turkey, so that's the item, and we're going to bake it for 3,000 seconds, 3,000 milliseconds. We then log out starting to cook, which is what we see right here, starting to cook the turkey. Then we do this thing called a promise. And so what ends up happening is we return this bake down here. So this entire thing is now pending. A promise has 3 states. It is either pending, meaning I'm doing stuff in the background. I promise that you're going to get this data eventually, but it's still pending. It is resolved. In other words, the promise is done running. I promised you data. Here it is. Or it is rejected. Shit hit the fan. Something went wrong asynchronously. The data's not there. You got to deal with it. So what we do is right here, when we create the new promise and return it, this comes down here and is now pending. And the computer is like, all right, it's pending. What then happens is it goes, all right, now that I have told this entire bake that the turkey's in the oven, that it is pending, right? The computer is going to pause right here and it is going to wait for this set timeout to run. It waits however long in the set timeout. It says it's done cooking the item, which we see down here as it is done cooking the turkey. Then it resolves. And this resolve sends up to the promise. The promise gets this return right here and goes back down to this then. Because the promise is now done, we then bake the pie. So let's see that in action a little bit more. We can write this a little differently. We can say cooking turkey is equal to a bake of the turkey for 3,000 seconds. Then we can log out our cooking turkey. When I do this, you will see that this says promise pending. Then it says done cooking, and we didn't put the pie in the oven yet. This promise pending is literally saying you just put the turkey in the oven, right? So this promise is not resolved or rejected yet. It's in its first phase of pending. So we're cooking the turkey and it's waiting for that turkey to be done. If I wanted to put the pie in the oven at the same time, I can actually do that. I can say const cooking pie is also bake the pie for 2,000 seconds and then console log out my cooking pie. We're going to see two things are now pending. And then it's going to say the pie is done at 2 seconds in and the turkey is done at 3 seconds in. So promises are a way to basically keep track of work in the background. Oftentimes, we aren't creating promises, but we are getting results back from promises that we don't control. What do I mean by that? When we fetch data from the internet, right? When we go out and make an API call, we say, hey, New York Times, give us this list of all the best-selling books right now. It will come back and it will say pending, promise pending. Like, I don't care that it's pending. Tell me when it's done. That is what this dot then is doing down here. It is saying, go do this thing, go get the data, go bake the turkey. Then when the turkey is done, go do this next thing. Okay. Call stack, call back queues, first in, first out. They are all either queue or asynchronous related. And queues can be asynchronous themselves. A call stack, I wouldn't say is asynchronous inherently, but it can be asynchronous. So the notion of a call stack can be, hey, the bake function calls the preheat function calls the check oven temp function, and the check oven temp function calls the smoke function, right? That is a call stack. That is a function calling another function calling another function. When you trace through the order that those functions are getting called, that is what a call stack is. So your function, if your functions are asynchronous, then yes, you could have an asynchronous call stack as well. But a call stack is just the notion of what the order that functions have been called, and that can be really helpful in debugging. These are callbacks. when a function passes data to another function, that is what is called a callback. So I will explore that example in a second. Um, and then first in, first out, is kind of the notion of how does the computer figure out what the next thing is that it's supposed to run. That gets a little bit over the computer sciencey line of things. But yes, they're all interrelated concepts, if not asynchronous to the general order that our code runs. All kind of related stuff. Um, then versus this, and what would happen if you didn't include the word new. Okay, so then and this are totally separate concepts. Then is for promises, and for asynchronous code, it is the way to say wait. Then is the keyword that basically says wait for this thing, wait for the promise to be resolved, and once it is resolved, then do this thing. Um, this, however, is object-oriented related. We don't get into object-oriented JavaScript a ton, but it is a um, paradigm. I'm going to say paradigm. I want to say methodology, but I think paradigm is the better word. Um, for um, for basically keeping track of variables in an object instantiation of a class. And so that is a object oriented is really hard to explain in JavaScript because when I say object, you think key value pairs, you think the values can be any data type, right? Objects are just a group of variables together. Object-oriented programming instead uses what we call a class, and then you have instances of that class. When you are trying to access variables inside the instance of the class that you created, you say this, and that's how you access the variables. So we don't use this a ton in our programming because we are not using JavaScript in its object-oriented form, which is why we don't see a ton of this dot anything in our code when we would for something like Java, for example. Does that answer all your questions? Or at least point you in the right direction? Cool. Okay. Um, the last one you had. What happens if we leave out the word new? So it says promise constructor cannot be invoked without new. That is because promise itself is object oriented. So when you use the new keyword, you are basically making an instantiation of a class. Promises themselves are object oriented. So you can't just say, hey, this promise, you have to say, no, 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 we want a new promise because you can have multiple promises going on at the same time. Date is the best example of this that we've seen so far. You can't just be like, date. You got to say, no, 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 I would like a new date that I can now work within, call different functions on, all of that kind of stuff. So the new keyword is required for promises because it is object oriented. And because of that, you need to create an instance of it in order to take advantage of them. And when you use the new keyword, you are basically making a new this to connect it into your other question. But then and this, two completely different concepts. It just so happens that promises are object oriented, so you would technically get access to this. That was a rabbit hole. Um, okay, so I'm gonna put the new keyword back in, and then can we say promise equals then? You could, yes, you could come down here and say, when the cooking turkey is done, then bake the pie. So we get started to cook the turkey, we wait 3 seconds, then we start to cook the pie, we wait 2 seconds, then it is done cooking the pie. Now keep in mind here, we cannot say all done baking. If we do that, we're going to start to cook the turkey's pending, then it's starting to cook the pie, then it says all done baking, it waits 2 seconds, and it says done cooking the pie. And I'm like, well, wait a second. You're not all done baking if you still have the pie in the oven. How would we go about fixing that so all done baking didn't come out until the pie was done?
I was gonna say, maybe add a timer to all done baking, probably.
We could, but there should be some way, right? Because if we look at the turkey, it started to cook the turkey, then it said it's done cooking the turkey before it put the pie in. Then it said all done baking, and then it finished the pie. So the order is correct on the turkey. It's starting to cook it, it waited for it to finish, and then it put the pie in. So how can we do the same thing to make sure that the all done baking doesn't come out before the pie is actually finished? The hint here is it's working on the turkey. So what is different about the turkey that is not happening on the pie? Then we are doing a new promise, right? Because we bake the pie. And if we look, we are returning a new promise, and we can log out the cooking pie here and see that the promise is there for the pie. You're on the right track there. We made the promise. What did we not do with the promise? We do resolve the promise right here. And we resolve the promise for both the turkey and the pie because they're both calling the same bake function. So only one step left. You guys are on the right track. We make the promise, we resolve the promise. What do we have to do? What's the transition between the promise is pending and the promise is resolved? What is the step after the promise is resolved?
We don't need another then, right?
You do need another then.
Ah, okay,
That
so
is
one thing.
exactly the right answer. We say, hey, we're cooking the pie. When the pie is done, then go log out all done baking. Now it cooks the turkey, it waits, it cooks the pie, it waits, and then it says all done baking. So that is a very common mistake to make, and why I made you guys sweat it out a little bit, even though the heat wave has finally broken. Um, it's very easy to start working on a promise, and it will give you an error that says promise is pending. And you're like, what do you mean the promise is pending? I told you to go bake the pie. What's going on? I wanted my baked pie out of here. I want to get the data. I want to get the type of pie it is and all that good stuff, right? Well, it can't do that unless we tell it, hey, you have to wait for this promise to be done. And when it is done, when it is resolved, then we can move on to the next thing. Terry,
Is there a limit of how many like thens you could have, or is it?
there is not. However, you queued me up perfectly for my next problem, which is now looking at what we're going on here. What happens when I want to put my mashed potatoes in the oven? Well, now I've got another problem where I can say, hey, my mashed potatoes are warming by baking the potatoes for a second. But then I have to say my warming potatoes then log out all done baking. Okay, now I'm baking three different things here. And we're seeing we've got a chain reaction going on here. We keep on indenting further and further over. This is what we call callback hell. Callback hell is when you get so nested within each other because you're waiting for all of these things to be done. And you're like, all right, there's got to be an easier way of writing this, right? There's got to be an easier way to say, look, I understand that the baking is happening in the background, but I'm standing in the kitchen drinking wine. I know that the stuff's in the oven. All I want to do is wait for the oven to be ready before I move on to the next thing. So we do achieve this, right? By saying, hey, cook the turkey, then wait for it to be done, then do this next thing. Then cook the pie, wait for it to be done, then do this next thing, put the potatoes in, wait for that to be done, then do the next thing, right? We go from this constant state of pending, resolve, then, pending, resolve, then. All right, we're following that through, but we're caught in callback hell. Callback hell meaning we have to keep on going another layer deeper every time we put another thing in the oven. So there's another way of writing this code. And this is the way that I prefer it. I never use .then because a lot of developers were like, listen, it's very easy to get caught in callback hell and lose track of your variables, of how many layers deep you're really getting. So what they said instead you can do is we can say, hey, we're cooking the turkey up here. Oh, wait for the cooking turkey. Then start cooking my pie and wait for it to be done. Then warm up my mashed potatoes and await the mashed potatoes. And finally, console log out my all done baking. Now, if we tried to do that, we get an error message. And the problem is in except for the very, very newest versions of JavaScript that aren't fully rolled out yet, it says await is only valid in asynchronous functions. Okay, what is that trying to tell us? It's trying to tell us that this await keyword doesn't know it doesn't know how to work because we basically just threw it in there and we said, wait for this code to finish. And it was like, you didn't give me a warning that things were running in the background asynchronously. And so we can't use the await keyword unless we call it in an async function. When we put it in an async function, it is saying, oh, I understand that things may be running in the background here. I'm going to keep track of those things a little differently so that when you tell me to wait on something under the hood, you've already warned me that there is going to be waiting happening in this function. So the way we do that is we say something like const cook is equal to an async function. And we put all of our code inside that async function, and then we tell it, hey, it's time to cook. Now we get the exact same results, It does my turkey, it waits for the turkey, it does the pie, it waits for the pie, it does my mashed potatoes. Then finally, it says all done baking. Okay, so this code and this code are achieving the exact same thing. So why is this important? Because there will be functions like this bake function that are returning a promise. When we say returning a promise, all we mean is it is returning something that is pending, and we have to wait for that pending thing to be done before we move on to the next thing. What do we mean by move on to the next thing? Well, there are two ways of doing it. This way does put you in callback hell, but it can make it a little bit easier to understand. Then do this when this is done. When this is done, then go do this next thing. When that is done, then go move on to this final thing. That gives us the flexibility of having multiple things in the oven if we need them to, but also saying wait for that thing to be done before we move on to the next one. This is called the dot then syntax. This is called async and await. We can't use this await keyword unless we put it in an async function. Once it is in an async function, right? Cook is just a regular old function. All we did is before the parameters, we said heads up, this is going to have some asynchronous code running in it. Because we have labeled it with that async keyword, now we can use the await keyword. The await keyword works just like the then keyword, but basically what it's doing is it's saying, "Hey, while while the turkey is cooking, don't move on to the next line. Treat this as if it were a synchronous line of code. Wait for the cooking turkey to be resolved, to be done, to be nice and brown and crispy into 165. When it is, now it is time to move on to cooking the next thing. But wait for that baking to be done before we move on." These two methods achieve the exact same thing, but it is a different syntax, right? And we find that some people really struggle with one, but really get the other. Either one is totally fine to use. This is the one that I prefer, right? This makes sense to me. Hey, I put the turkey in the oven. Now just wait for it to be done before we move on to the next section. However, some people do find that the dot then syntax makes more sense to them because they're saying, "Hey, this thing is happening in the background. Then when it is done, go move on to this next section of code." Okay, I know it's kind of a complicated subject. How are we feeling about promises and then versus async and await? Async and await are still using promises under the hood. They are still, a promise is just a way to keep track of some code running in the background. So when we ask that thing to run in the background, it makes a promise that is pending. We then take that promise and either await the promise to be resolved, to be done doing whatever it needs to do, or we also wait for that promise to be resolved and then have it do the next section of the code for us. It is something that you will get practice with APIs. Promises are kind of hard to emulate without an external place to go ask it to run the code. But a timeout is a really good example of, hey, this thing's running in the background. I can't just move on to the next thing until that thing is done. So we can either say when that thing is done, then do this next section, or we can say go do this thing and wait for it to finish before we move on to the next thing. Can I list a few real life API examples? Yeah, absolutely. So, weather is a really good example, right? Of, hey, I want to know what the temperature is outside. New York Times, I already mentioned, is a project that you guys will be working on. When I come back, we will use a Owen Wilson API, which literally returns him saying wow in almost every movie that he's been in. And we will use that data to make a little interface and practice with our API calls. You can do API calls. Actually, the bot that I built for when the recording is available on Zoom, right? That's an API call that comes into my bot, and then my bot uploads it to YouTube. So APIs are usually what we would consider a wrapper around a database or an access point to a database. An API doesn't necessarily need to have a database behind it, but APIs tend to be the layer of code that work between our database and the actual internet, right? To pull information out of it, to update it, all of that kind of stuff. With that said, an API doesn't have to have a database behind it. It just often does. I'm trying to think of some other, like Free Code Camp has an API that you can pass in your username and it will return back all the challenges you've completed, and certificates you've achieved and accomplished. Um, Canvas has an API, right, where I can pull back all of your grades, all of your assignments, and APIs can be two-way data as well. It doesn't always need to be pulling data. So I can use the Canvas API to upload your grades, right, or leave a comment on one of your assignments or something like that. So an API is just when our code is talking to someone else's code, and it usually happens over the internet. There's an API. What was the dumpster fire year? Was that 2021? They built a robot that was hooked up to a printer and a treadmill, and you could send an API call in, and it would print out a message uh, on the printer, and the treadmill would pick it up and dump it into literally a fire in a dumpster. That I thought that was a really cool, fun project. And then the API would send you, would email you the clip of your message getting printed out and sliding into the dumpster fire that they had created. So yeah, lots of fun APIs.
I have a question about you said the Canvas API.
Yeah,
So you use that to you said like change our grades or make a comment without like going into the
I
website,
could.
like the UI.
Yeah, yeah.
Oh, okay.
I
And how
I I don't, but I could. Yeah.
from like a
Uh,
terminal or something?
Yeah, so that's what you're going to be learning this week. You're going to learn how to use curl, CURL, lowercase c, and then capital URL, which is how to send API calls in the terminal. And then you are going to learn a tool called Postman, which is basically a UI built for developers who are working with APIs and sending data back and forth. And then finally, you'll learn how to do it in your JavaScript itself, so that you'll be able to build interfaces based off of the data coming back. So it's a kind of a three-step approach. But yeah, you
Mm,
hit the nail on the head.
that's cool.
All right. Any other questions about promises? This is not something that you need a ton of practice with. I'm not saying you need to be masters of it, but we try and expose you to it to understand, hey, how is all of this working out? The last thing I need to show you here is that when we resolve a promise, it can come back with some data. So I'm going to say, when I'm baking my item, I'm going to resolve it with a little message. Let's say, uh, let's just say we're going to return an object with the time of however long it took to cook that thing. Okay, now that I have that time resolved, I should be able to log it out. So if I come down into my then example, I can access the resolved data right here. So I can console log out my resolved data dot time and see, hey, my turkey, once it was done cooking, took 3 milliseconds, 3,000 milliseconds, 3 seconds to log that out. So the problem that you get into with callback hell is, well, what if I want to get my cooking pie logged out, right? So I'm going to say um, it took Well, if I come into my cooking pie, I can then get access to my data that's coming out of the promise. The problem that I run into here is that I already called something resolved data. So I now need to be careful what I name this. I'm going to say I can name this pie results. And then I can use my pie results dot time to get that information back out. Uh, sorry, this should be resolve data time. So now it's cooking the turkey. It's waiting for the turkey. It is saying that it took 3,000 milliseconds to cook the turkey. Then it's coming in and getting 2,000 milliseconds to cook the pie. So this last flow that I want to show you here is that when data is resolved, we can send information back, and that's like returning the information when the promise is done running. So we take whatever data is getting resolved here and we send it into the promise down here with the then. The downside to callback hell, and this often happens, right? Sometimes you'll make an API request to the New York Times and you'll say, hey, tell me what all of your bestseller lists are. And they say, we've got fiction and nonfiction and all of these things. And then you're like, okay, but I want to know the books that are on the nonfiction list. Well, now I have to wait for the first API call to be done, figure out what data I want in it, and then use that data to make a second API call. That's what happens here. When the data is getting resolved right here, I can then get access to whatever data is resolved and log the information out. But if I'm basing a promise on another promise, I then need to be careful about what I name where that data is sitting. So that data is now coming out in time. And so it is logging that out down here. I don't like this result. I don't like using dot then. I don't like that syntax. Instead, I like this a little bit more because with this, the data coming out is stored in my variable. So what I can just say here is console.log, and I'm going to just comment this one out so we don't. Now, when we run that, we get the same exact result, except this was undefined because I didn't await for it to be done baking. So that is the last thing I will say on this before we move on to our next topic. If we don't await the data, notice what's happening here. It's starting to cook the potato. It does say that it is done cooking, but what did we not do here? We didn't wait for the data to be done. So when I tried to access the mashed potato warming time without the await keyword, it told me it took undefined to cook the potato. Why did it do that? Because we waited for the pie to be done baking. The pie came up and said, "Hey, I'm resolved. Here's how long it took." It then moved on to bake the potato, but it didn't wait for the potatoes to be done baking. So when I said, "Hey, how long did it take to bake those potatoes?" It told me undefined. I don't know how long it took because it's not done yet. The promise did not resolve itself. So what I have to do up here is say, wait for the potatoes to be done baking. And now when I run that code, I get my turkey, my pie, and my potatoes, including that it took 1,000 milliseconds to cook the potato. All right, how we feeling about promises? We feeling like this went right over our head? We feeling like we just need more practice with it? Give me some feedback on this.
For me, I think it's just getting used to the syntax.
Okay. Okay, so we are going to, well, before I jump into that, are there any questions that have come up? Has anyone been working on Free Code Camp or Odin Project and hit a thing that they just totally don't understand? Has anyone hit a moment in their capstone where they have no idea how to approach that or even get started and need help? Is there anything that I can help you with before I leave you for 3 weeks?
Yeah, I'm stuck on the last part of the free code camp is the use recursion to create a range of numbers.
Okay, share your screen. Let's take a look. Recursion is a topic that we purposely don't get into. Recursion is most frequently helpful when you are writing a loop where you don't know exactly how many times it is going to run. And that is when recursion is the most helpful. So we talk about for loops and while loops and do while loops. And then there are other things like mapping and filtering and all of that stuff. But recursion is something that is really easy for us, for really easy for the computer to do, but really hard for our brain to understand because our brain doesn't think about calling itself over and over again. Okay, so um, with that said, recursion is often a question that comes up on technical interviews, which is why I would like to go over it with you in class now, as opposed to saying, push it off for a one-on-one. Okay. Um, we have defined a function named range of numbers with two parameters, parameters meaning the data that we're sending in to the function. The function should return an array of integers, which begins with a number represented by the start number parameter and ends with a number represented by the end num parameter. The starting number will always be less than or equal to the ending number, so the starting number will always be smaller. Your function must use recursion by calling itself and not use loops of any kind. It should also work for cases where start num and end num are the same. Okay, so um, what we're going to do here is say, hey, if they pass in 1 and 5, it should return out an array 1, 2, 3, 4, 5. If it's 6 and 9, it should return that out. Okay, so what we're going to do is we are going to say, return let's say if the start num and the if the start num equals the end num, we've reached the end of our loop. So just return um How are we going to keep track of? Can I make the array out here? If the start num and the end num are the same, um, go to the range and push whatever the start num is, and then um, return the range. Otherwise, just going to do this no matter what. Oh, apparently I can't cut or paste. Come on. Otherwise, we are going to return range of numbers, and we're going to take one more than the start num, and the end num is going to stay the same. And then we can call range of numbers 1 through 5. Start range as an empty array. Range of numbers. And console log. Range of numbers. Okay, looks like that worked. One through 5 should return. Global variables should not be used to cache the array. Damn, I thought I could get away with that. Okay. So I have to return the array every time. Um, uh, all right, give me a
We
second.
want we want to use like a switch for this, right?
Um, no. Um, all right, let's try and do this differently. So let's say there's always a condition in recursion that says when the loop should stop running. So the loop should stop running if the start num is bigger than the end num. Um, and if it is, return out an empty array. Because that's handling the case of where the data should start from. Then we say else keep track of our numbers by calling the function again, this time with the start num being the same, and we want to get to the point where the end num is smaller than the start num. So we're going to say end num minus 1. Then we will push, when we're keeping track of our numbers, whatever our end num is, because that's what we keep on taking 1 off of. And then finally, we're going to return our numbers. Okay. So let's talk through that. We're not. Okay, so what's happening here? The we start out with 1 and 5, right? So we say, okay, 1 is our start num, 5 is our end num. Is 1 greater than 5? No, it's not, right? So we ignore this if entirely and we come down into this else. And the else is saying, hey, go call range of numbers again. But this time, instead of 1 and 5, it's going to be 1 and 4. So it goes, okay, go back up here. We still haven't completed the first time of all of this running, but go up here, go check, is 1 greater than 4? No, it's not. So go down here. Now our second function is still running in the background. It's waiting. We come down here, 1 and 3. Okay. Haven't hit that yet. We get to 1 and 2. We come up here, 1 is not greater than 2. We hit 1 and 1, and it goes, okay, now return 1 is not greater than 1. So we go 1 and 0. 1 is greater than 0. Start with an empty array. So we go 1 stack up the call trace, and we go, all right, when we sent in 1 and 0, it gave us an empty array. So that's going to start with our numbers. Now, take whatever the end num was, which was the number 1, and add it to the array. Then return numbers. But now we got to go another layer up. Numbers now has the array of just the number 1 in it. So we now have 1, and our end num was 2. So now go push 2 into the array. The array now has 1 and 2 in it. Now we go up one more level and repeat. 3 gets pushed in, return out the array, go for 4, go for 5. So you got to think about it as I get all the way down to the end. I hit the end. That means I start the blank array, so I've got something to push it into. And as I work my way back up the call stack that got me all the way down here, I'm going to keep on pushing the numbers in. And then finally, return out all the numbers.
So it just keep going and going and putting like the number inside of the array, and then when it's done, it like give us the array back.
Yes.
Okay.
Right. So you think of it as we're not doing anything on all the way down, right? So on let's just say the range of numbers was just 6 and 7, right? This doesn't hit when we call the function for the first time. Then we come in here and we say 6 and 7 minus 1 is 6. 6 is not greater than 6. So we've hit the bottom. Now we have the empty array. Now we have our starting point. So the first time that this recursively calls itself, all numbers is an empty array. Then our end num was 7. I'm sorry, it was 6 because we subtracted 1 from it. So push the 6 in. Then return numbers, our array with just 6 in it. We run this again because we are going back up the stack. We get 7 here, and then that's what gets returned out.
Yeah, I definitely need more practice with recursion for sure.
Recursion, I'm just warning you, is it's a really challenging thing because our brain doesn't think that way. Our brain doesn't think about the function is called the first time, and that function has now asked itself to run again. So you always need an escape case for the recursive function. You always need an if statement in a recursive function, just like you need an if statement in any kind of loop that you run, right? It may not be explicitly written as if, but there is always a condition. When should this stop running? When should this loop be finished? Whether that's a while statement, whether that's a for loop, or that could be an if condition in a function that calls itself. But you basically have to say what happens when we get to the end of the loop. And once we hit the end of the loop, what's all the processing we should do to get back up all of the different calls for that? This might be one that like a diagram is kind of helpful to see it running out.
Yeah, I would think so too. Like the diagram probably helped me a lot.
All right. Any other questions?
Can we do if possible a little activity practicing the promise and resolve? Well, before I ask that, are we gonna be talking about that with the guy that's coming tomorrow? What's his name
Yes,
again?
yes. Um, if you may not be talking about it directly tomorrow, but you will be getting practice with it the next 2 weeks plus the break in between.
Okay.
Because APIs are all promise based, right?
Yeah.
Because we may be making an API call and it could take 30 seconds to get that data back, right? And oftentimes when we're making an API call, we don't want to wait for the call to come back for the rest of our code to run. We may want to put up a little message that says loading or get snarky and be like, wow, this is taking longer than we thought. Or we may have some other code, right, that the user can interact with. And when they click on this button, this thing should show up. Well, we don't want to make an API call and then have all of our code blocked until that API call has been done and has brought the data back. And so that's why we need promises to either say, hey, when that data does come back, then do this thing. Or we can write in our code, hey, make this API call and then await for the data. And when the data does come back, that's when you'll get practice with it. So here's what I'm going to propose. Let's take break a little early. Let's go on break, be back at 7:05. When you come back, I will have some practice promise exercises for you, and then we will do another section in the how to adult topics. Sound good? Cool. Go on break, back at 7:05. All right. Got a little practice for you guys to do. And then we will finish up the evening with another section of the how to adult. Um, so I just put a link in the chat for a little challenge for you guys. If you have any questions, let me know, but you're going to basically create a new file like you guys are used to doing HTML script.js. And then you are going to copy and paste that array in, right? That array is all of the magic 8 ball responses. And then you're going to use a promise basically that says, hey, let the user know, hey, the ball is seeing into the future. Wait 5 seconds because the future takes time to see into, and then log out one of the random responses by resolving the promise. So you can use my code as a example. I am going to push that up to GitHub right now, or you can pull it from the live share, of course. Okay. Link. Anyone have questions about the challenge out in front of you? Okay, I'm going to start a poll so we know where we are at. If you are throwing in the towel, and no one better be doing that in the first 3 minutes, but if you are ready to tap out, feel free to vote for the no option. But I will give you guys a couple minutes to work on that and let me know in the poll when you guys are done. Or if you get stuck anywhere or have questions, happy to help. While you guys are working, a reminder, let's do attendance before I forget. The keyword, you guessed it, is promise.
Could you repeat that for me real quick?
Promise is the keyword for attendance.
Thank you.
Anyone completely and utterly stuck on a certain number? You can put it in the chat or ask the question too. You guys 5 more minutes to work on this, and then we'll move on to the next subject. But if you have any questions, feel free to ask them.
I got a question. Sorry if my vacuum is loud, but I'm on number 10
Mm-hmm.
and it says using the then syntax, use a variable for number three. I went back to number three. Are you referencing the const
Oh,
responses or
oops, my bad. Sorry,
the
I
one
added
we?
new numbers and totally forgot about it. It should be number 6.
Oh, oh, oh. I could have deduced that, but thanks.
Sorry. Thank you.
It's okay. You're welcome.
I think the same issue for number 11.
Pesky numbers be the death of me. So number 10 is definitely like the hardest part, 10/11, because that's when it all comes together, right? So if you get stuck there, that is the crux of all promises. Give me 1 more minute and then we will go over the answer. If you are just joining us, promise is the keyword for attendance. All right, where are you guys at? You want another minute or you want the answer? About
Another
half
minute.
another minute? All right. After you guys have voted in, it's about split of who's accomplished it and who hasn't. So give you one more minute and then we'll go over it. All right, let's go ahead and give this a go. So I'm going to start with number 5 just because I've got my terminal set up to run all of this. I copied and pasted my responses in. I am then going to console log out shaking the ball. Then I am going to create a new promise. So I'm going to say const seeing the future equals a new promise. That takes two things, a resolve and a reject. And then I said inside the promise, console log out seeing the future. Then I said, make it wait 5 seconds. So that is our set timeout. What goes in the function of the set timeout is what it waits to do. And then we say 5,000 milliseconds for 5 seconds. Then we say resolve the promise. What does resolve do? It says, hey, this data is now ready. I promised you the data. Now here is the promised data that is coming back. And we resolve it with a random selection from our responses array. So all of this code is doing is picking a random response. It may be a little bit more clear if I say const random response equals that big thing, and then we can resolve with that random response right in here. This doesn't do anything. If I go run this, and well, if I run the right file, just as shaking the ball, seeing the future, and we never actually get the random response that's coming out, right? This promise is running, but we then need to tell it, hey, when the promise is done running, then I need you to do something. So we say console, no, we say seeing the future dot then go get the selected response, and finally console log out the console log out the selected response. Sorry, I noticed a typo in the instructions and then wasn't paying attention to what I was typing. Okay, now shaking the ball, seeing the future, we wait 5 seconds. Then this random response is picked. It resolves the data, which is coming down into here. It is then getting the then, dropping the resolved response into selected response, and console logging it out. The other way of making this work is making a function that is asynchronous. This async keyword gets us access to the await. So we can say await seeing the future and console log whatever the response is out. And so when we call shake the ball, we can also see the response, which is, as I see it, yes. So based off of this example, do we have any questions about promises? Did anyone get caught somewhere? Is this a good exercise for practice? How are we feeling? Obviously, not you don't have to answer it exactly this way. You could have, named your variables different or done a couple different things, but the idea of making a promise, resolving the promise, and then doing something with the promise. Everyone good? Last call for questions on this.
Wait, quick question, or I guess
Yeah.
clarification. So the then is basically like saying, do this code first and then do this.
Yeah, so basically what we're saying here, right, is hey, I'm gonna ask you to shake the magic 8 ball, and I need to wait until the ball's die has bubbled up and the response is there before I can do anything else in my code. So the two different ways that we can do that is we can say, hey, this is all the work that happens to actually shake the ball, make this response come up, all of that stuff, right? That goes inside the promise. But when we use the promise, we say, go do this promise thing, and you are going to be pending the data until the data is resolved, which moves it to the second stage, which we can then take the resolved data and do something with it. Right. So you can think about this. The biggest use case you have for this is going to be I am going to make an API call and I can do two things. While that call is pending, I can either wait and then do something like log the selected response, or I can, as long as I am in an async function, say, hey, go do this thing and just await it to be finished. And then we can do something with the response.
I got a question.
Yeah.
How is resolve reject working?
So resolve is basically filling the first parameter of the callback or the returned result from the await. Reject is a little different in that you can catch a rejection. So in here, don't follow me on this, but you could reject and say, and then down here, you could do it with a dot catch and a
Oh, so you append the catch to the end of
in a dot then, yes. So
right.
now it's gonna wait 5 seconds. It's still going to eventually uh and catch. Well, that so originated by throwing inside of an async function without a catch block or promise resolving that was not handled without catch. Well, I thought that should work. Oh, you know what? It's this is causing the problem. There we go. So that's the style of a rejection if you're using dot then and chaining. The reason why I like await, if you do this instead, is that you can actually do it in a traditional try catch block. and that I like that syntax a little bit more than the dot catch. But that is how you would do a rejection in a promise. And oftentimes you would reject a promise like if it was taking too long to run, or that it ended up resulting in not data that you were expecting or something like that. You can't quite throw things in JavaScript like you can in a promise. And so because of that, you use rejection as an alternative, and then can either catch it with this syntax, or if you're using await, because that is uh, built into JavaScript, you can use the catch with it.
Oh, so does reject natively define errors or pull from natively like if it's labeled as an error, that's what it's detecting or looking for, I guess.
Yeah, it's basically the equivalent of throw in JavaScript. It's just how the promise engine is implemented that they basically build in rejection to kind of emulate a natively thrown error.
Gotcha.
I have no idea why they didn't just use throw, but I think it has something to do with the call heap and not having access to getting data back through. So when they were building out the resolve, they also said, hey, promises will oftentimes fail. And so we should be able to reject them as well. Good question. Any other questions on this?
Yes.
Yeah,
My promise isn't working. Can I share my screen?
sure can.
Where is it? Oh, can you see it?
Mhm.
Sorry, the Zoom thing just like gets right in the way. Oh, okay.
Um, you are resolving with an array, and you should be resolving with parentheses instead.
Oh, to make it a string.
Uh, no, no, no. You were right to not have it as a string, but those are square brackets. They're not parentheses.
Oh,
Resolve is a function that you're calling.
okay. Let's see.
Oh, no, 35. You still have square brackets instead of
Oh,
parentheses.
did that?
And it shouldn't be a string. It should be your random response variable. Yep. And then the last thing you need to do is step number 10 on the instructions.
Oh, the thin. Okay. Hmm. What's the syntax for that? I'm
You're gonna
blanking.
do the data that comes out of whatever you're resolving right here comes in here.
Okay.
So you can call that really anything,
Oh,
as long as you're consistent, and then you can console log the resolve data. And that should better
nice.
not
Oh,
tell you
that's a
now.
good response to my question.
You
Thank you.
put me on the spot. I didn't have a exercise prepared for this, and I'm like, ooh, this is a really good one to practice. Like, magic eight
And
ball.
and I was thinking like, oh, I don't want to put him on the spot, but oh,
And I
that's
didn't
interesting.
use ChatGPT once. You should be so
Oh,
proud of
that's
me.
good. I am proud.
All right. Any other questions on this exercise?
I do have a question.
Yeah.
So looking at now commented out, but looking at line 38, I believe it is.
Mm-hmm. Yeah, here, let me flip these so it's a little easier.
Or rather 37. So the selected response, how does the computer know that the selected response is essentially equivalent to responses, open parentheses, random response?
Yeah, so whatever is in the resolution here will always be whatever the first parameter is down here. So you can kind of think
Mhm.
of it as a for loop when I say like for let car of cars. Well, the singular plural makes sense, but I can really call car anything that I want. I could call it a singular car. Um, it's always going to be whatever is getting sent in from what we're looping over.
Yeah.
The same goes for the promise resolution. So basically, whatever is in right here always gets sent to the resolve here, which gets sent to the seeing the future here, which gets called down here, which then waits for the resolve of the then here, and ultimately will take whatever is in here and dump it right in here.
So the resolve does return the value in a way.
Yes. Yes.
Okay. Okay. Yeah. Thanks for the clarity.
And I hesitated on that because down here, when we use the await keyword, it actually is returning it, right? Like that is the value is there. Here, it isn't returning it necessarily to seeing the future, but it is giving us access to the resolved variable through the callback of the dot then. So is it technically returning it with a dot then? Maybe not, but we are getting access to the data. We just happen to use a callback for the dot then, or it is actually returning the value if we use the await keyword, which is the primary reason I like the await keyword so much more, is because you just shove it in a variable. You don't have to do callback stuff and get lost in functions and block scope and all of that. But totally personal preference, both work. Any other questions on this? Promises are one of those things that you try to avoid as long as you can, and then all of a sudden you start making API calls and all kinds of things that are asynchronous, and you kind of get forced into having to use them. The one thing I will leave you with here is if you just remember when a function is asynchronous, and the documentation will always tell you, hey, this is returning a promise. All you need to do, if you want to oversimplify everything that we've done tonight, throw it in an async function, put the await keyword in front of it, and chances are you will be totally fine and can avoid all of the promise stuff. We have to cover it because asynchronous programming is a part of every programming language, and you can't make API calls using fetch, which is what's built into all the browsers, without promises, async, await, all of that stuff. There is a very good chance that you will not be making your own promises where you have to resolve and reject and do all of that stuff. But what there is a very good chance of is you using a function that returns a promise. And literally all you have to do to avoid all of that headache, throw it in an async function, remember to call the function, and put the await a keyword in front of it. If your brain is fried, those are the three things I would take from tonight's class. And then when I get you back from Ryan, we dive back into Owen Wilson. And that's kind of hopefully where his teaching style ends and my teaching style picks up. And a lot of people get light bulb moments there because Ryan is just a very different style teacher than I am, which is good. It's a good exposure. It's not a good or bad thing. It's just different, right? So as you're learning from him, keep a list of questions going. Obviously, ask him all of that stuff, and then when I come back in, we basically do a review of everything that he covered in his 2 weeks. Joe, question.
I've briefly used Axios before for a project a while ago. Doesn't it kind of tweak how promises work a little bit?
I believe Axios uses Bluebird, which is a promise solution that existed. Don't quote me on any of this because I haven't used it in a while. Bluebird was a promise solution that existed before browsers and Node natively supported promises, or if they did, they weren't doing it very well. And so Bluebird was an alternative to promises that handled them better. And then just like get elements by query selector, promises kind of got better in native Node and browsers. And so because of that, a lot of people have now moved off Bluebird and to actual native promises. So that syntax is would be supported with native promises. It's just a matter of how Axios is returning it. If it is using a native promise or not, I'm not sure. But we will use fetch instead of Axios because fetch is kind of like jQuery in that it used to be pretty bad and you had to do XML requests, and Axios was just a much easier way of making API calls. And now fetch has gotten so good that there's not really a need for a third-party tool anymore. With that said, if I were forced to pick a third-party tool for making API calls, it would be Axios. We use that, I think, in the first two cohorts, but fetch has just gotten good enough that there's no reason to add overhead with a API library.
I see. It looks pretty similar, assuming that's correct. Yeah, the
Yeah,
syntax is much
that's
more
pretty
readable
close.
than
Yeah.
what we were doing
And
today.
if you ask for that using async await instead of .then, it becomes even easier to read. All right, final call for questions on this. Terry, what's up?
So we should be able to utilize like promise with the other projects we did, like the rock paper scissors and or like the tic-tac-toe thing, right?
Yeah, might be overkill. You may be able to get away with just using set timeout on those without having to use promises, right? Promises are more helpful to say, wait for all of this other code to be done before you move on to the next step. So you can accomplish a lot with just a regular set timeout and just moving the code into the set timeout. But we kind of use set timeout to emulate the notion of a promise taking time to resolve. So normally when you are working with promises, you won't be making your own promise. Instead, fetch or whatever you're using will say, hey, this returns a promise, and all you need to do is say, wait for this promise to be done, or do this thing, then do this thing next. So most of the time you won't be making promises. You'll just be waiting on promises to resolve with .then or await. But yes, you totally could use promises in other projects. It's just a more advanced level of JavaScript.
And for the extra challenges I see at the bottom here, um yeah, I'm not even gonna attempt that. I mean, I at first I was going to, like, it says move like the promise into the function so you could ask the ball multiple times, multiple questions and stuff. I'm like,
Yeah.
yeah, I'm not really too confident on that yet.
Just wanted to put it out there in case anyone like finished it in 2 minutes and was like, all right, let me give myself a challenge. But you know, no big deal if you don't want to push yourself on those. And this isn't anything to turn in. This is just an opportunity to say, all right, I thought it was sinking in while Max was teaching it. Now let me challenge myself and give myself the opportunity to see if I'm really getting it.
I think I might do it like when I like rewatch like the video again, just so I can have like a better understanding of it.
Yep. And I do in the example here, I do have it in a function, right? So this is an example of having the promise in a function and being able to recall it. What I didn't do an example of is a loop in this, right? Where I could very easily set up a for loop. You can do all kinds of fun stuff with the of an example, right? You could say, hey, I want to have the turkey in and the turkey has no other space, so wait for the turkey to be done, but then put the mashed potatoes and the pie in at the same time. And then they may have different cook times. I mean, you could build your entire Thanksgiving meal in this to get more practice with promises and understanding multiple things in the oven and what we wait for and all of that kind of stuff. And Ryan is a pro with teaching promises as well, so you will get more exposure to this and see more real world examples with APIs. Okay. I got you for another 30 minutes. Let's see how quickly I can get through one section of the adulting, and then I will hopefully get you guys out of here a little early. Okay, so a lot of this stuff I think is when you hear it, you're like, well, duh, that's just common sense. But when you kind of put it all together, I think it makes it click a little bit more. So I really like to think about organization, about feeling like you're an adult, right? Because a lot of times in life, you're just you feel like you don't know when you crossed into the adult threshold, but you may not be doing it. You may not feel like you're doing it very well, right? So I feel like whenever you're organized, it's really the best feeling of being able to tackle anything, even if you're feeling overwhelmed, because you've got a really good structure and foundation built around you. So start with digital organization. This is something that I recommend every single person does. Use a password manager. Apple actually just announced a couple weeks ago that their password manager is complete and utter shit, and it will be totally overhauled in the next version. So I am very excited about that. In the meantime, I have used 1Password for years. LastPass and Dashlane are two other ones. 1Password is I want to say like $60 a year, $30 a year. They've got a good family pack as well. So it's not entirely free, but it is worth every penny to me. I have over 1,000 passwords stored in there. I have not had to reset a single password since I have started using Dashlane. So it is a pain, or 1Password, sorry. I used Dashlane before 1Password. So it is a pain to get set up. The beauty of it is that it syncs across all of your devices. So once you get the passwords randomly generated and stored in 1Password, if there's ever a breach, you never have to worry about changing your passwords on every different website, because using a password manager like this, your passwords will be random and it all syncs. So when you're on your computer, the autofill just works. And then when you go to your phone, the autofill just works. It is amazing. So really, really recommend using a password manager, and most security experts do as well. Terry.
What do you mean about like a password manager? Is it like some sort of like application, or is it
It's basically an app that's a database of all of your passwords. And so there's a Chrome extension, a Safari extension, a Firefox extension, and then there's a mobile app as well for iOS and Android that integrates into it. But basically, all it is a list of all of your accounts. And then it has the website that it's associated with, your username, and your password. The idea here, though, is that you don't use the same password across all of the websites. Instead, when you create the account, 1Password will pop up and it says, hey, do you want to randomly generate a password? And you hit yes on that. And because every website gets a different password, if there's ever a breach and those passwords get leaked, you don't need to worry about that random password being used on other websites to sign into other accounts. It will be secure because it's unique for that website.
is that also another reason why people recommend that you change your password like every like what I think it was every 3 months?
They do if you're using the same password across a bunch of different websites. And so the utility here is that all of your passwords are stored securely in one place. But the real benefit of using a password manager like this is that they generate random passwords for every unique website that you have. Joe.
Just wanted to point off on Terry's comment there. A lot of organizations, including Onondaga County, moved away from incremental or interval password changes due to the fact that most people find a password that they have. They'll have like say password, a number, and a symbol, and every time that interval hits, they'll just increase the number one and increase the number one. So it's not really that secure.
Yeah, a lot of places have been dropping those password requirements. There's also now a movement for pass keys, which are actually require a password manager to store them, and they're like a really long string that are forced to be randomly generated. So that is coming down the line. Like I said, Apple will have a better password manager built into all of their tools when iOS 18, I believe, comes out in the fall with Mac OS and all of those updates. But I highly recommend 1Password. And I used Dashlane for years. Dashlane was great until I hit about 1,000 passwords stored in there and it started to slow down on me. So that's the only reason why I switched. Still recommend 1Password, but Joe probably put the most important thing in there. Do not lose your master password. Your master password is the literally why 1Password is called 1Password, is the one password you still have to remember. And if you lose that master password, you can call up Dashlane or 1Password in tears. And they're like, sorry, your data's encrypted. We can't get you access to it. And so what 1Password does is they generate what they call an emergency kit, which is a PDF that you print out. And that is like a long key that gets you into your account if you get locked out. And it's meant to be something that you like put in your safe or keep with your passport or birth certificate, all that kind of stuff, which we'll get to in a second in the slides. And I forget how Dashlane does it. I think Dashlane will do emergency access, so you can like set up another contact, and then if you get locked out, they can help you get restored in. But anyway, yes, remember your master password. Very, very important. But the reason, again, 1Password is called 1Password, it's the one master password you have to remember, and then you can forget all of the other ones.
I got one more question. So you don't recommend Google, because I see Google got a password manager too.
Google is about as good as Apple's right now, which is, in my opinion, still pretty lacking in features compared to 1Password. I find 1Password or Dashlane is worth paying for at the moment. I think Apple getting into the game will make it one step better, but I still would be surprised if the seamlessness that 1Password and Dashlane bring to password managers, I would be surprised if Apple hits that level in the fall. Um, I think it will be better, but I think Google and Apple are on the same level right now, which is not great. And Apple and probably Google within the next year or two as well will start to catch up to 1Password and Dashlane, but I don't know if they'll fully get to that level. That's good to know, Joe. I don't touch betas with any of my stuff until like GM 2 weeks before it goes live. I used to, but not anymore. Um, I use Google Drive for all of my files, especially anything paper-based, right? I have found it so beneficial to scan things in and use a really simple naming structure. So I have everything in a folder called Docs, right? And I don't put any like Google Drive files that I'm creating there. My docs are literally meant to be, I'm scanning this in. This is something that got mailed to me. This is something I need to respond to. This is a ticket that I got, or whatever it is. So I do docs as my main folder. I create a 2024 folder, and then I name everything with month, day, year format, and then just a quick little file name for it. Whether that is a bill I'm paying the plumber and want to have it on record in case it breaks and I need the warranty information, whether that's something that I got in the mail that I need to keep track of, whatever it is. I think people will over organize paper files. And so I recommend skipping, not overcomplicating your organization, especially for things that you're scanning in. Scan in any paper or mail, chances are you're never going to find it again if you have it sitting in a folder. And then you will go years and find the folder again and realize that you needed to throw it out a long time ago. So I really recommend keeping everything digitally, and try to be careful about not duplicating any files or having multiple copies of a project. You will get lost in that. That especially goes for your capstone. So if you are keeping multiple copies, make sure you are being very explicit in the naming of them, but try to avoid that as much as possible. Have a digital backup, whether that's the cloud, iCloud Drive, Google Drive, Microsoft OneDrive. All of them are fine. I use a service called no, it's Backblaze, not Blackblaze. Yeah, sorry. Backblaze. That was a typo. Backblaze is, I think it's $120 for 2 years, maybe. Don't quote me on that, but it has unlimited backup and will back up your entire computer, which is really handy. So I like that as kind of a set it and forget it if you're looking for a cloud solution that is outside of the three big tech companies. And then Time Machine is another really good option. I will note that we wipe your computers at the end of the program, if you guys get to keep them. So thinking about backups now is a much better solution than thinking about backups when we get to graduation and you're in crunch time for your capstone. So Time Machine is built into the operating system. It does a really good job of backing up your computer to a local hard drive. Do not think that flash drives are the same as hard drives or solid state drives. Flash drives are notorious for failing on you without any warning, right? One day it's working, the next day you plug it in, and all of a sudden it won't read, it won't show up, your data's not there, and you just blink and it's gone. However, hard drives do not have that problem. Hard drives do still fail, but there is a newer type of hard drive called a solid state hard drive, an SSD. It is the same kind of hard drive that is in your laptop itself. It has no moving parts. It has very low failure rates, and it is blazingly fast to write to compared to what we call a spinning disk or traditional hard drive. You can get like a 500 terabyte, 500 gigabyte solid state drive for around $100, give or take. And that can be a great one-time cost. Time Machine will back up to it. You can plug it in once a month, back up your computer. Really, really good idea. So cloud backups are a great option, whether you're storing the files there directly, whether you're using a service like Backblaze that backs up your whole computer, or whether you're backing up locally. Just please, for the love of God, do not back up to flash drives. I've had so many people lose data because the flash drive just stopped working one day. Okay, any questions on that stuff? Okay. Important documents. Invest in a fireproof safe if you haven't already. At some point in your life, this is just a great way to know that all of your documents are together. Don't store anything in it that is not important. Don't throw bills in there. Don't clutter it up. Really try and keep this as your sanctuary of all of your most important documents. I'm not saying bills are not important, but they are not something that you want to put in your safe. So this is for passports. This is for birth certificates. This is for social security cards and your car title if you own your car and you have it paid off. important to have all of that together. A lot of people wait for this and go, oh, I forgot about my social security card, or I never got that from my parents, or whatever it is. And then you need to go get something like your driver's license. By the way, Real ID is coming right around the corner, which means you won't be able to fly with your driver's license anymore unless it is a Real ID. So something to think about there. But this is one of those things that is a pain to get when you need it right away, but really easy to get if you go, oh, I forgot I don't have my social security card, or I don't have my birth certificate. I should try and go get replacements for those. So if you don't have a birth certificate and social security card, consider getting that replaced before you actually need it. ID cards, you can get a New York ID for minors that makes it much easier to fly with your kids, and is a much cheaper alternative to a passport. I think they're only $5 or $10 for minors. And then for your ID cards, heads up, Real ID is something that is coming, I think, within the year. Again, you won't be able to fly with your license unless it has a star on it, or says enhanced, or has the US flag on it. The newer license will say not for federal ID purposes. TSA is a federal agency. So yes, you won't be able to get into a nuclear facility, but more importantly, you won't be able to fly unless you have either a Real ID or an enhanced ID. And of course, getting all of that means another trip to the DMV, and you need two proofs of address and all of that kind of stuff, but something to put on your radar if you are someone who flies. Any questions on this stuff? Okay. Next fun thing, getting ready to die. Ooh, isn't that a cheery thought for everyone? So, couple things of when you die, the your family is going to have enough grief that they are going through, or loved ones, or partners, or whoever. And so I wrote a blog post on all of this. I believe I posted these slides. I will post them again if I haven't. That has a link to that. But these are some documents that you should have in place, especially if you have any dependents, thinking about where your assets are going to go. Ideally, you work with an attorney on these, but there are a lot of websites online that will help you generate them. A will is last will and testament. How are my possessions going to get broken up? Who do they go to? A healthcare proxy is really important for, hey, someone else should be able to help me make medical decisions if I am incapacitated. You would think that the law would just pass that on, and it doesn't always. And then the other really important part here is a HIPAA authorization. HIPAA authorizations, believe it or not, you can have a healthcare proxy. They can try to make decisions for you and be told that they don't have access to your medical records in order to be making medical decisions about you. So HIPAA authorization is really important. Living will is really good for saying, hey, while I'm still alive, I want these decisions to be made about my healthcare. And then power of attorney is kind of a something that everyone should, not everyone should do, but you should consider, of basically, hey, if I'm in a coma and I need my bills paid, or I need someone to talk to the bank for me, power of attorney is one of the most powerful legal documents that you can sign, that basically says this person can act on my behalf. And they can make all decisions for me. So again, that's not something that you necessarily will want to have signed and ready at the ready. But I've been in 2 comas, and so I am a little bit paranoid about all of this stuff. I want to make sure it is easy for my people caring for me to be able to resolve this stuff. And so this is the list that I think is really important. Just something to consider. Any questions on these? Not an attorney, not legal advice, just a list to look into and consider for right before you die and right after. All right. Day-to-day living. This may sound like common sense, but live your life out of a calendar and a to-do list. I cannot tell you, every successful person I know lives their life out of a calendar, and that goes into retirement, right? If you are not going to bed and checking your calendar for the next day and waking up that day and living your life out of a calendar, it is a really, really important thing to do. A lot of people think that their to-do list and their calendar are the same thing. They are not. Your to-do list should always be prioritized, but it isn't, and the to-do items may have a due date, but they aren't necessarily scheduled items, right? If you need to schedule time to get that item on your to-do list done, that's totally fine to do. But having a list of, hey, here are the commitments I have made. I've said I'm going to show up for this meeting at this time. I have a doctor's appointment. I have whatever it is that goes in your calendar. I have to get this thing done. It may have a due date, but I just need to keep track of all of them. Those are two separate things. So even if you don't have a lot of appointments, living your life out of a calendar is transformative, even if you may not be doing it yet. Respect your time because you'll start to respect others' times, and that in turn builds their respect for you, right? So being true to yourself and saying, hey, my time is valuable, whether that's some task that I'm working on to better myself, or whether that is a task to help someone else. So give yourself some credit for your time. Your time is value and deserves respect. This is something that I have seen change over society. We hear the term respect your elders all the time, right? And I think that our society has been slowly moving away from that and saying, well, why should they get respect just because they're older, right? That borderlines on ageism and discrimination. So I think we are shifting our society to a point where respect is no longer assumed, it's earned, right? Of, hey, if you respect me, I'll respect you, and valuing each other a little differently. So just something to think about there. Okay, when life comes at you too fast, first and foremost, always take notes. I am never more than an arm's length away from a notebook. There are times that when you start a new job, when you are reaching the second half of the boot camp, when you are stressed out at work, whatever it is, there are times that life comes at you too quickly. The number one solution I have found for this is taking notes. Whether that's a whiteboard, whether that's a notebook, whether that's sticky notes, whether that's a software tool like Trello with a to-do doing done, whatever it is, find the thing that works for you. I've got sticky notes, I've got my notebook, I've got a whiteboard over on the wall. I use a combination of a lot of different systems depending on what kind of work I'm doing. So find the thing that works for you if you haven't already and stick to it, because it is so important that when things do start getting too quick for you, you can have a system to rely on and help you balance it all out. At the end of every meeting, someone should be identifying action items. You should not be meeting for 30 minutes or an hour, getting to the end of the meeting and then realizing that you don't know what to do next or who's responsible for the next steps. There's a great book called The 25-Minute Meeting. That is the reason why all of my meeting one-on-ones are only 25 minutes. But do not waste people's time spending all of that time together in a meeting and not knowing what the next steps are after it. All right, I think this is my last slide. Stress and anxiety are not the same thing. I absolutely love this graphic. Stress is a normal part of life, right? And it is normally short term. It is your body's reaction. It is literally can be chemically measured with cortisol levels. It is in response to a recognized threat, right? And whether that is hopefully not physical, but it is a short-term thing of, oh, I have a deadline coming up. I am stressed out about it. Anxiety is different. Anxiety lingers. Anxiety is something that you may want to consider mental health treatment for. It may not have an identifiable trigger. This is when you are waking up for the 5th day in a row and you can't quite figure out why you're stressed, but you know that something is off. You know that your emotional well-being isn't quite right. So a lot of people use these two interchangeably, and they are not. So if it is stress, identifying what the cause is allows you to engineer yourself out of this. And this goes back to my last slide. Write things down. Why do you guys have rubber ducks? Because communicating outside of your head is what is allowing you to work through the problem. The same goes for stress. Identify what is causing the stress, and before you dive headfirst into it, plan your way through getting out of it. Figure out everything that it's going to take to get that thing finished, and go from there. This type of engineering happens to be called project management, and you guys have heard me talk about how important that is to the nth degree. And then finally, treat your life as a project. Oftentimes, when you are feeling stressed, you can work your way out of it. Okay, what do I mean by that? Consider organizing your life into weekly or bi-weekly sprints. Think about everything that you need to get done in the next week or 2 weeks. Plan everything out. And then when something does pop up, you can prioritize that and say, hey, is that something that I can push off to the next sprint, to the next week? Or is that something that I need to prioritize into my current list? Hold yourself accountable with scheduled retrospectives and postmortems. This can be a great way to start your Saturday morning or end your Friday night. Hey, what did I commit to doing this week? What did I get done? Sharing that sense of accomplishment and pride. And then also postmortems, right? The flip side of that, yes, I know I'm talking about death a lot tonight. Shit hits the fan, right? Things go wrong. And breaking that down and figuring out, hey, I survived it. It went wrong. We're on the other side of it. Identify what went wrong, thinking through um, how you solve the problem, creating documentation. So if this problem happens again, you can easily jump on it, thinking through the communication that was happening and your support network. All in very important things, right? Of yes, things go wrong, but recognizing that, planning through it, being prepared for it, really helpful. It's not just about what you have to do, but what you've accomplished, and that's really about what the retrospective is for. Engineering is just breaking complex things into smaller pieces. Treat your to-do items the same way, right? Don't think about just being good at coding as breaking things down. Find a way to take that skill and apply it to the rest of your life. And time management becomes much easier when you know to start by identifying what needs to be done. It is impossible to manage your time unless you know all of the demands on your time. And while that sounds like common sense, a lot of people think, oh, I'm just bad at time management. No, you're bad at thinking through all of the things that you need to manage your time on. If you start with that step, allocating the time to getting those things done becomes 10 times easier. I work 2 full-time jobs. I know the importance of this. I would not be able to do all of this unless I had project management that worked for me. At the end of the day, I account a lot of that to a notebook, but I do spend at least an hour a week sitting down, thinking through what tasks need to be done, communicating that, delegating out to team members, making sure I'm not roadblocking people, all things that I have to do in my day-to-day life, and also what I do for, managing my house and getting projects done and having contractors in and all of that stuff. It feels a whole lot better when you have the list of everything that needs to get done. I am going to get you out of here 8 minutes earlier. The next section is things I wish I was taught sooner. We'll get into healthcare a little bit. We'll touch on investing in the stock market. We'll talk about IRAs and 401ks and traditional and Roth and all of that good stuff. But I am ready for my vacation. You guys don't get one until next week, but I am out of here. If you have any one-on-one things for one-on-ones, feel free to schedule with me. If you have any questions about the stuff that I just blazed through, feel free to ask them. Otherwise, have a great rest of your week. Ryan will see you all tomorrow, and I won't see you until the capstone check-in. So don't forget about that. Any questions? Doesn't have to be about
Yeah.
this stuff either.
You got me on a kick of changing all my passwords now.
Good.
All the ones that I've been too lazy to go change.
I'm guessing you are a Dashlane user.
Yeah, I've never heard of one password. Dashlane, I think, was the first one that I'd come across. I think when they were really pushing hard on marketing and stuff, and I checked it out. I put it in the chat, but of course I remember exactly where I was too. I signed up, I made my long 32 character password, my master password, and then promptly forgot it.
It
And I was
happens.
like sitting for hours, like it was probably like 7 or 8 hours. I'm like, I got it.
Um, Yeah, my mom got locked out of her iCloud account, and it was because I misspelled our cat's name. That like I had when we were like 5 or 6, and it was, like my first password ever. And just totally misspelled it. And she was like going back and forth with Apple forever. Then I was like, no, it's an E, not an A. And she's like, no, it's not. What do you mean? And like literally flipped out the 2 letters and like got back into the account. So anyway, yeah, I'm a huge fan of using password managers.
It makes
It's a
life simpler.
major security thing, and once you get it set up,
Yeah.
it it is a pain to get set up. It's a pain to change all your passwords, but once you get it all done, it's worth it.
Oh, you know what it was that dragged me to Dash Lane? They don't have it, which is ironic, but they were advertising bulk password changes.
Mm,
Um, that you could select what accounts you wanted, and they would go through and change the
yeah, I
passwords
think they
for you.
still have it, but it just doesn't work great.
Yeah, I'm
Um,
assuming it gets caught up in like 2FA stuff and
yeah, yeah.
just a mess.
Bitwarden Terry is definitely like I've definitely heard of it. I haven't personally used it like I have 1Password and Dashlane. So I have heard the best reviews from 1Password more than Bitwarden and Dashlane and LastPass or the 4 other ones. Um, I'm a big fan of Wirecutter, which is like New York Times um review website. And they will hit you with a paywall once you start reading like enough articles. But they have done a review of password managers. And so I really like that because like Consumer Reports will just like give you the table. And they're like, well, here's what we recommend because it was like a 4 out of 5 noise level or whatever, right? And I really like Wirecutter more because it's written like an article. So they not only say like we like 1Password, but they'll actually say like this is why we picked 1Password. Also great Dashlane. Here's why we picked 1Password instead of Dashlane, right? So it's not just like hard data that they're throwing at you. It's instead they go through and like kind of explain everything out. And so I know they have a password manager article, and that may be a better place to start.
Yeah. I got Bitwar because I was looking at it. It was like, oh, single is like free, and I want to do like free for now since I'm kind of a little low on like income. So, and I guess I didn't realize how important it is to have like a password manager and stuff because I just usually rely on my Firefox to do the little. Oh yeah, you said your password. Oh yeah, let me just paste this password for you. So that's the reason why I asked.
Yeah, it looks like it's 1Password's $3 a month. But Wirecutter does say that the best budget pick, it says Bitwarden, the best free password manager. So yeah, that I'm sure it's a good option.
Don't forget to
And
export and import all your passwords from all your browsers.
yeah, and start trying to change your passwords as well to completely random ones, which is hard to like trust in the system and have faith in it. But as
That's
long
why
as
I
you don't,
haven't.
yeah. But as long as you remember your master password, I'm telling you, every time I'm screen sharing with someone and they're like, "Oh, I don't know my password. I have to hit forgot password and like get the email link." I'm like, "What are you doing with your life? There's a better way to live."
Unfortunately,
Oh,
I used to be one of those. Like, I'm like, oh crap, I forgot my password because I use like five different like passwords, and they're like, oh wait, which one was this again? I don't feel like doing all five passwords. Let me just hit the forgot password to my email and stuff. So unfortunately, I am one of those, but I'm trying to change. That's why I'm using Big Void. So
Good, good.
hopefully, like,
I changed
I don't know.
mine. Currently, what my system is, I'm gonna trust in Dashlane. I'm gonna let go. I'm gonna let Dashlane take the wheel. But what I've been doing is every 6 months, I'll change the password. It's probably about 20 characters. And I'll change it, but I'll still use that for a lot of different things. So it's easier for me to keep track of the accounts and stuff. But I'll let Dashlane decide what everything's gonna be.
Have faith. It's I have found it to be worth it. A good trick that someone did tell me was like, in order to make every like have the same base password, but then look at your keyboard, and if you're like on um apple.com, you put your base password in and then you make a V on the keyboard. So A is the first letter of Apple. So you append one QAZSE4, right? Which is like the V of where A is on the keyboard. And then that way, if you're on Best Buy, you would still use your same password, but then at the end you would append 5TGBHU8.
Oh,
And then you
I
were
see.
getting a not a random, but a semi-random password for every website. Now, obviously, that doesn't work because any website, if you're on Yahoo, that would be the same as your. Oh no, sorry, there's one off there. If you were on Target, that would be the same as your Best Buy password. But that was I thought a good trick for having different passwords for every website.
Yeah, I don't do that for the big ones. My email, which has all the other linked passwords, my bank, um, anything else that's like highly secured, they're all separate passwords.
Apple is the only one that I have a separate password for. Everything else is in one password. Down to Google, everything. I mean, if I got locked out of my Google work account, we use sign in with Google for everything. Um,
Right.
but I
Yeah.
have you could hold a gun to my head or give me $1 million and I couldn't tell you what my Google password is without my phone or laptop.
What's the what are the numbers, Max? I don't know.
Like legitimately, I have two passwords
Beats
still
me.
memorized, and oh, that's not true. I guess the password on my Mac isn't completely random. Three passwords: my Apple iCloud, my Mac password, and my one password.
Oh yeah, I always forget about the sign-ins for the devices. All right. Well, I guess I got a day-long project now.
All right, I will see you guys.
Bye. Enjoy your vacation.
Yep, enjoy
Thanks.
your vacation.